wanted to talk about today was, first of all, a little bit about Peak Energy, the company that Caitlin and I are both working on. But I wanted to put it in context, and the context I wanted to focus on was how can we create, found, scale companies in today's day and age and the financial environment that we find ourselves in. And so, sometimes we call Peak Energy a reverse startup, and we'll talk a little bit about what I mean by that. We'll also touch a little bit on a concept that one of my partners at a previous life at Eclipse Ventures, Charlie Mwangi, would call third generation companies. And there's a whole thesis around investing in the third generations of companies because they can just move so much faster than the very earliest folks. So we'll put it in context. So a reverse startup, what does it mean? Everybody says, oh, start with the market. But what does that actually mean? When we went to go look at building a company, we wanted to do something to help solve one of the biggest problems in today's day and age, and that is the growth in electricity demand. Electricity demand, I think everybody's probably aware, 50 years it's been flat in the US, like literally no growth. And over the last 3 years, we've started to see a growth curve that is starting to develop. Partly it's driven by AI and data centers, but actually the larger kind of macro trend there is really around the transition from burning fossil fuels to electrifying everything. I mean, even though oil and gas fields are electrifying. Why? Because it's more efficient. And so this is a long, we think, trend that will continue for a long time. And we started with, well, how do you solve this problem? And got to the conclusion that actually battery storage is probably the most impactful thing you can do over the next 5, maybe 10 years. Everybody likes to talk about natural gas, nuclear, those all have room to play, but they are certainly not going to make much of a dent in the next year, 2 years, 5 years. Battery storage, on the other hand, it's really about unlocking unused grid capacity. There's over 100 gigawatts of capacity that we could unlock from clean power without adding any generation to the grid at all. So our conclusion was this is the most interesting asset class in energy. We're going to go build a company there. Notice we did not start in the lab. We did not start with a technology in mind. We started the company in conversation with the big guys in the space. So we were having conversations with NextEra and AES and Jupiter Power, folks who really are trying to solve this problem, in the real world. So we do have a technology solution to it, but it was an existing technology that we started to see scaling first in China, but it's a technology called sodium-ion batteries. It's actually a cousin to lithium-ion. It's made on the exact same production lines as LFP, so it's not a massive, kind of reimagining of the manufacturing footprint. There's $1 trillion in the ground now making lithium-ion batteries. We can leverage that. But to our view, this was really a better fundamental choice for solving large grid-scale batteries. Like I came from lithium-ion batteries. My last company was a lithium-ion company. My co-founders were all in lithium-ion. It's great, but it was invented for mobile technologies. It's in your phone. It's in your mobile device called a car. It's really focused on energy density and performance. And of course, as the EV space scaled up, it became the default choice for grid storage because it's at scale. It's certainly cheap, but in our view, not cheap enough, especially in the parts of the grid storage space that actually matter, where the money actually is. And here's a hint, it's not actually in the cell. It has some other benefits, safety, abundant materials, supply chain, et cetera, that we think made it the right fundamental choice for grid storage, and it was starting to scale, and that's the big and. For us, looking, just because the technology has the best fundamentals doesn't mean that it can compete in these massively scaled markets that we all are operating in. And so the trigger for launching the company was actually seeing it start to scale in the most important place in the world for manufacturing of batteries, which is China. So we have a team in China today. We've been spending time there since before we started the company. Saw the trigger that was happening there and said, okay, this is something that's going to be important worldwide, but even more importantly, we think this is especially a good fit to our home market here in the US and then ultimately the Western world. So why? So it turns out sodium ion has never been the choice to come out of the lab historically because its energy density is lower than lithium. So terrible choice for your phone. Arguably not a good choice for your car, although that may change here over the next couple of years. But great choice potentially for grid storage, where that energy density penalty really is not probably a defining characteristic. On the other hand, cost, massively important probably in all of these markets actually, safety, and ultimately it's the chemical stability of the sodium ion chemistry that makes it so attractive here. So if you think about what is a lithium ion grid storage system today, you know, it's a giant containerized thing. There's probably 2, 3, 500 of those all deployed into the desert. But part of the reason why that's such a complex and expensive thing to do is that those lithium ion cells need to be kept at 25 degrees C, plus or minus 2, or you're not going to hit the 20, 25, even 30-year lifetimes. You've got to be constantly monitoring for safety. Even with that, it's kind of a physical inevitability that we're going to see fires, mostly caused by all that complex equipment that is supposed to be keeping the battery cool and safe. So the kind of the killer app for sodium is actually not that it's a lower cost cell, although it will be, isn't today, by the way. It's that its stability allows you to really rethink from the ground up kind of the entire architecture of how we deploy these batteries. And so, you know, what you see in the slide there is basically those things highlighted in yellow are all of the systems and components that actually don't exist and have been deleted from our system. Like our view is, if you're gonna make really large, low-cost, grid-scale batteries, it should be really simple. You should never have to touch it. You should not be doing preventive maintenance on it. It should last for 30 years without, I was gonna say a better word, but without screwing up. And so that's what we set out to do is develop a system that is dead simple and really from first principles does what we needed to do, which is just sit there, charge and discharge every single day. So that's what our product looks like. Like I said, it's got superior safety, zero preventive maintenance, lasts twice as long as LFP, so things like augmentation and overbuild have a big economic advantage on these systems, you know, et cetera, et cetera. Why does that all matter? Because in ESS, it's actually not about the cell, it's about the project. And you know, the used to be that cells were the most expensive thing in the project, right? Back when cells were $200 a kilowatt hour, $300 a kilowatt hour, that was what everybody focused on. Today, the cell cost is actually probably 10% of the total project cost. And this is something we as battery engineers have to always remember. It's not all about the materials in the cells and the performance of those cells or even the cost of those cells. We're buying sodium ion cells today. They're $10, $15 a kilowatt hour more expensive than LFP. Yet on a total cost of ownership project basis, we're $50 to $70 per kilowatt hour cheaper than LFP. And that's on a supply chain that's not fully scaled yet. It's a company that's certainly not fully scaled yet. But we're winning because we're going after where the money is. 2/3 of the money is actually OpEx, not CapEx. China does a great job of massively down costing the CapEx. Cells are going cheaper and cheaper and cheaper, but you could get a Nobel Prize for, you know, taking LFP from $40 to $30 a kilowatt hour, and it would be like 2% of the total project cost. So it's actually about the project, it's not about the cell, it's not about the battery. So where are we now? So we've got over $1 billion of committed contracted offtake. We delivered our first 3.5 megawatt hour pilot system in Colorado last year, and we're moving into deployment in the next couple of months on first 3 or 4 projects this year, which are relatively modest, but have managed to convince Jupiter Power, which is a BlackRock company, one of the top 3 storage-only IPPs, to put almost $1 billion behind this vision of sodium ion being really the right technology for this market. And they're using that to go win PPAs that they otherwise would not have won. Their, you know, their win rate on their customer projects is like 5 times higher what they were predicting. And so their pipeline is more than doubled from what they were predicting starting in 27, 28. Why? because they have a competitive advantage on cost based on the technology that they were leaning forward to go after. So how did we get to $1 billion in offtake when we haven't even delivered anything? And this is one of the points that I really wanted to emphasize. So remember, when we started the company, we started it in conversation with the best customers in the market. And when we started thinking about, okay, well, in our business, bankability is the big word, right? Like, what does that actually mean? It means, how do you get your technology to a point where you've de-risked enough that a bank, which is about as risk-averse a financing engine as there is, will go ahead and give our customer a loan to go build a $200 million project. So how do you do that? And the way the utilities and the IPPs think about it is that, oh, well, we'll run a pilot. And everyone you talk to says, oh yeah, we'll do a pilot. All right, so $500,000, $1 million bucks. Costs you, of course, way more to do that because you're subscale. And before you know it, you've done 10 pilots, run out of money, and you haven't actually moved the business forward. And so we said, okay, we're not doing that. We're going to do a pilot. We're going to call it a program, give it a cheesy name, the Peak Pilot Program. And we're going to invite customers to come into our program that we pay for. You're going to help us build a system, set requirements, review of all our test data through the whole development. So 3 years we've been working with these folks. We had 9 or 10 of these guys sign up to this. But the most important thing was, the quid pro quo was, if I let you into my program and we meet the requirements that we set together and we agree on economics, you will do a project. Otherwise, I don't want you in my program. It's like, you're just wasting my time. And so we had 9 companies sign up to that, commit to do projects with us, and the first of that is that Jupiter deal. So we think this is, one way to achieve bankability. We think the idea of paying for our own pilot and then inviting a multitude of customers to come do what they were all going to do themselves, but it's basically a duplicated effort 10 times over. We should all just do that one way. And of course, it's a cheat, because of course we would go work with those best customers in the world. Of course we would ask them for their input. Of course we want to know what their requirements are, but this is a way of kind of formalizing that process so that every 6 weeks, they've committed a team who's going to go review that, and they're going to give us feedback. So that Peak Pilot Program was really key to our go-to-market motion and ultimately bringing us to where we are. There's a lot to it, like a very sort of detailed bankability study for all the things that we think we needed to get, and we're, 80% of the way there now. Now we're like arguing with tax equity and insurance companies on warranty, warranty insurance, et cetera. So we're sort of at the end of that. But just suffice it to say that we tried to map this out from day one so that we knew we could get to a point, really, end of this year, where somebody's willing to loan our customer, but really us, those hundreds of millions of dollars to get scale. So what's next for us? Obviously, AI data centers is on everybody's mind. Really interesting space, I think, that's happening now as we, our sort of core business around building these projects, most of the, maybe not most, but certainly half to 60% of the contracts that we have today are backed up by a PPA to a hyperscaler, right? It's bring your own power. But what's really, I think, exciting there is that as you've seen these new rules come from PJM, FERC, et cetera, with a, not only bring your own power, but bring your 200 hours of curtailment to the system. It's basically breaking the whole architecture of, of backup and BDUs and then longer term backup with diesel. So we're starting to see some of these bigger announcements around long duration storage. I think that's part of the answer. The other part is large scale BESS directly on the power pad at these data centers that can ultimately go and address multiple use cases within the overall architecture. So kind of a longer term trend that's developing. Everybody loves, especially investors love to talk about AI and hyperscalers, blah, blah. Little hint, they're actually the most conservative customer out there, even more conservative than the utilities, because it's all about reliability and it's all about the reliability that they need to serve their customers. And they're new to batteries, so doing something scary like buying a CATL system and then thinking about, okay, well, maybe there's a better solution from a startup company that, you know, is ultimately going to be in production and will have all this data. It's a really tough sell. So I think longer term, this is a huge opportunity, but it's a little bit longer term. And then for us, you know, when we started, we thought we would be moving upstream and potentially we'd be doing cell manufacturing and, you know, kind of vertically integrating. Instead, what we've chosen to do, given the capacity that's in the world now, and given that our product can be made on LFP lines, we're going to leave that to our partners. We're starting to move downstream. So in addition to selling the technology, the equipment, et cetera, which is a really high growth part of our business, we're now starting to invest in developing our own projects. And we can buy a project at NTP, replace the lithium technology in that project. Normally we would have a 10% IRR hurdle rate. With our lower cost sodium, we can boost that IRR to like 15% and buy the equipment from ourselves and then ultimately flip the project to an owner operator. So there's some different business models I think are really interesting to explore as technology providers that allows us to kind of access more of the overall value stream. So let me talk about this final concept, and that's the idea of a third generation company. There's a lot on the slide, but you know, at its core, there's this concept, and you know, I learned this from my partner Charlie Mwangi at Eclipse, of different generations of companies that get built as technologies get developed. And you can think about it in EVs. You know, when Tesla started, there was really no technology base. There were not even people who had ever really built EVs before. So they would recruit people from other industries. They would teach the supply chain how to do, you know, look, a flat screen panel in a car did not exist. So they had to go find somebody who would do that. Same with batteries, same with motors, same with inverters, et cetera, et cetera. Most of the Gen 1 companies will fail. It's such a huge effort, takes so much money, but there will be a handful that succeed beyond anyone's wildest dreams. Tesla's a great example of that. Then there's the second generation, you know, maybe Rivian would be a good example where they can hire people from that first generation, so they have a trained workforce. There are vendors and suppliers who've been active in the space. You don't have to convince them that there's a market there. Everybody knows there's a market, so you can move faster. And then eventually you get to the third generation where now you have an entire industry, an entire ecosystem that's been built out. And you can build businesses on top of that. So now you've got fleet businesses, you've got Uber, you've got, you know, other fleet managers, et cetera. And these are the businesses that oftentimes can be the fastest to grow and ultimately can become fantastic investments. And the same dynamic, I think, is playing out in the battery space. So if you think about like the first battery companies to get to scale, how hard that was, you know, the CATLs of the world. Second generation companies, my company Innovix, I would put them in that category, but you know, this is like Amprius and 14 on the silicon anode side. It's also the solid state battery guys solving really hard problems, but it's one problem and then leveraging what exists in the world. I mean, there's actual battery equipment that you can buy to make batteries, right? Stuff like that. It's the software infrastructure that goes into battery R&D. We had to write that ourselves originally, right? But now there's companies that go do that. And then I think right now we're at the start of kind of third generation battery companies. And this should be a note of optimism for everybody in this room. Raising money is super hard now, I think, for batteries in particular. All VCs hate batteries, just so you know. They say they don't, but they do. Everybody's lost money in batteries, except for those who haven't. But it's a small list, and despite the massive need in the world and the huge business opportunity, I think there's a lot of scar tissue there. But in fact, we're at the third generation now. That means a company like Peak, and I think, you know, there's many of us in the room who are in this exact same sort of situation. We're able to leverage the infrastructure, the industry, the people of an entire industry go fast. And we can focus on the application layer rather than the fundamental science necessarily, right? And you can see the difference in timescales. So I don't know if you can really see this slide, but we asked Claude to do some analysis looking at what we would think of as sort of peer companies to us across various different areas. These are not all battery companies, but just let's call them energy companies, whether it's thermal or whether it's all the different flavors of energy company that are out there. Some of which are now becoming quite successful. There's a bunch of announcements about companies going public here in the next call it 12 months, etc. But the time scale is super long, and part of the reason for that is that most of those companies are Gen 1 companies. They're the first of a kind doing whatever it is that they're doing, and that takes a long time. It takes 10, 15 years. But a third generation company, we're just one example of this, but if you look at Base Power or Loom or any of these guys, we're getting commercial milestones that are 2-3 times faster than those first generation. And so that's a really optimistic thing for folks who are trying to scale their companies now. This is a great time to invest in those companies, because I think there's going to be some mega companies born on the shoulders of all the work that's come before us. And a lot of pain and suffering, a lot of scars for all of us, myself included, in the battery space, but I think it's actually a golden time to go build an energy storage company or a battery company today. Okay, so what are the lessons? So start with the market, not the technology. We literally started with the market, and we didn't even have a technology. We also decided that we would build with customers from day one, and we wanted to take what was available today and ship it as soon as we possibly can. And so we were able to build first systems fully operational in the field within 2 years. Contrast that to my last company. I think our first real product took 12 years of slogging through R&D, getting it qualified, etc. It's really, really hard, trust me. So we decided to do it in reverse. Deploy what we think is the best solution today, get real commercial traction. And by the way, we're not ignoring the technology, we're investing in that in parallel. And this being the battery world, we think the next generation of sodium-ion technology will be 5 years out, maybe 10. But at that point, we'll have a platform to be the first to go deploy that. We talked about Gen 3 companies. I really believe these can produce outsized returns, particularly like the real world returns, meaning IRR, which has a time component to it. And this is really a fantastic time to go build those in our particular industry. And then the final one, of course, be willing to be wrong. When I first met my co-founder, I was at Eclipse. It was his first day. We recruited him to bring to the company to go incubate a company in grid storage. He said, "Cam, why don't we go work on this? You've been in the battery space." And I said, "Nothing will ever beat LFP. Can't make money in grid storage, and I'll never start another company." And 4 months later, we took our first seed funding from Eclipse. I quit my job as a VC, and here we are. So be flexible. It's okay to be wrong. I'm wrong most of the time anyway. But if you can course correct, maybe you can get something done. So thanks, everybody.
We do. I was going to say, we can maybe take 5 minutes here if anybody's got questions for Cam, and then we'll transition into a break. Anybody got any burning thoughts? See one over here.
Oh, thank you. Wonderful talk, Cameron. I'm pretty sure some of these points are going to get repeated across, but you made a good point about the Gen 1, Gen 2, Gen 3 companies. How much of that is a function of where in their manufacturing readiness level stack you started? Because some of those Group 14 and obviously sure, they started intentionally very early in the TRL stack. So you have to overcome the value of debt, yada yada, right? So how much of that is a question of speed versus the starting point?
It's a good debate. I think this is a fairly generic framework. I think it's less about where you start in the stack, and the concept here is more about what resources are available in the world that you can just buy. Do you have to invent and make the sneaker to start running the race, or can you just buy a pair of Nikes and off you're going and you're focused on the race instead of kind of the core technology? So that's how I've always sort of thought about it, is like, how mature is the industry? Is there a cohort, not a cohort, but an entire population of people who are trained and have had experiences that you can just go hire? Are there vendors who exist in the world who produce half of the stuff that we had to go invent the first time around because it didn't exist. And then ultimately, it's an entire ecosystem that's been built for that. And yeah, your question about like where are you going in the stack and how much innovation are you trying to do and how difficult is that particular innovative path, those things of course matter in terms of both the outcome if you're successful, but also the speed to get there. But there's no question if there's all that stuff around you, you don't have to worry about that stuff. You can just focus on the one piece.
Any other questions? No?
All right, Chris.
Oh, yeah, go ahead.
Great discussion. Appreciate the context, the background, how you got to where you are now. When you were talking about going downstream and focusing there on more projects and bringing those online, I'm not sure if I heard you correctly on one topic. In terms of the cells, you were initially planning on making those. Are you suggesting that now you may, or you may outsource those while focusing elsewhere at the system and project level?
Yeah, when we started the company, we knew we had to buy the cells to execute the strategy. Like you don't build a battery cell factory in 6 months and then go to market. So we cultivated really good relationships with a number of cell suppliers who make sodium-ion batteries. To us, we've continued to innovate on the chemistry package there. So we have some know-how and some IP. We thought we were going to be required to build a cell factory in order to compete in the ESS market, which has pretty strict domestic content requirements on the tax side. And so with that in mind, that was going to be the plan. And what has happened, in fact, due to a lot of different factors, some of which are negative things like the slowdown in EV growth, et cetera, there's just a huge amount of excess capacity in LFP. Of course, those are the lines that can make our cell. And so we decided about a year ago not to be a cell supplier. And it's allowed us to free up bandwidth and capital to move downstream instead of upstream and capture value not just on the hardware and software that we build, but then ultimately invest in the entire project. And we think there's actually a whole bunch of sort of product development to be done around the project. So we think the whole project should be our product. And we think the whole project, rather than from where it's come, which is, hey, we need grid storage, let's go take a bunch of EV batteries, throw them in a container, put them in the field, and then wire up the inverters, et cetera, with an army of electricians. I mean, it's not that bad today, but it's not that far from that. We think that whole process should be an integrated product that gets built in the factory, that you can control the cost and the quality, and ultimately that's how we're going to drive outsized returns. So, it's one of those things. We didn't have to do the cells. We think we can control our destiny around the cells because there's some technology that's there. But that's freed up bandwidth and the financial resources to go downstream. And ultimately the mission of the company is to produce the lowest cost dispatchable electron in the world, and I think we're part of the way there. So.
Thanks, Cam, for the discussion. Let's give it up for him one more time.
Thanks, everyone.